Hello and welcome to Next Day Solar. In this episode we'll show you the fitting of solar panels and lots of Victron energy equipment to two brand new LDV Maxus electric vans. We're here in Barnoldswick in the north of England at Cool Van. Let's show you what we're doing inside. So this is where all the magic's happening. These are two brand new LDV Maxus Deliver vans. Now LDV was a UK company bought by a Chinese company recently. They've developed this as one of their pioneering first electric vehicles. We at Next Day Solar were super excited about it because it's one of the first vans to have a range of up to 200 miles. This is our first van that's been fitted, and it's got a fridge system in it as well as a solar panel roof. We've got lots of Victron gear that's being installed inside, and it's fitted with two 212 amp hour lithium batteries. Well, this is Michael, the lead and senior engineer here at Cool Van. Now we've had a bit of history with Cool Van. Back in 2019 we had some of our first Renault Kangoo ZE electric vans from Cool Van, and they fitted batteries in and a small solar panel on top, and that was the start of our journey into solar. Michael's now been fitting some new kit to these new LDV Maxuses. I sent Michael this wonderful line diagram by email recently with all the kit from Victron and said, look, have a go and see how far you get. And we've come today to have a look at how he's done and see how we can add some more kit onto the setup. So Michael from Cool Van is going to take us through where they've got to so far with the setup. So Michael, over to you.
Yeah, so we've fit the lithium ion batteries into the back of the load space, like so. Going through the shunt to monitor what's going on in the batteries, state of charge and any temperature and anything like that, which then the wires run through into the side, down the back of the bulkhead between the steel bulkhead and our insulated bulkhead. From the batteries, the wires come through the bulkhead into the cab, through onto a bus bar. So we've got the main battery feed to the bus bar, and then we've got the wires coming down from the roof, which from the solar panels, into the smart charge controller, and then we've got the fuses through the power all the way down to the bus bars again, and then you've got the Victron Energy display unit to see what's going on with the batteries.
Fantastic. So it's a really nice setup, and Michael's done an amazing job so far in kind of getting us to this point. And today we're going to have a look at what else kit we're going to add to it. So if you follow me, I'll show you some of the stuff we brought here today. So the van is set up to function and work, but there's definitely a lot more equipment we can add to make the van better. The first is the Victron Turbo GX, and that will take an input, a VE direct input from the MPPT charge controller and also the BMV 712. So that will give the system real-time information about how much energy we're gathering from the sun, how much energy our fridge is using, and the state of charge of our battery, and that will be accessible to us back at base, so not only with the driver on the road, which is what the BMV will give you, but also a global readout. We've got Ethernet ports, and that leads us onto the Teletonica router, which is a Lithuanian router which will give us 4G data coverage wherever the van is. And we've also brought along the smart touch display for the Turbo GX, and that will be in the cab, giving that driver full visibility of how their battery is doing, so they know how much more cooling capacity they've got and how long they can be on the road for before that chilled section of the van starts heating up. So that's really good. And then we've just brought along all of the Victron cables. Victron do great cables, RJ45s, VE direct cables, and we've brought along some more Victron bus bars as well, just to make sure that all the wiring and cabling is done really, really well. So we're going to make a start. We're going to have a look at how Michael's done so far, and then look at starting to add on all the extra bits of kit that we brought with us. Let's go. So we're just disconnecting the batteries now. I'll just explain kind of one thing that I've been talking to Michael about. So, and right now you've got one battery, and that battery is wired to the other battery, and then this battery has basically got all the connections out to the whole system. That's not best practice, and we want to have a diagonal setup here. So we want to make sure that positive current is coming off one battery and negative current is coming off another battery, and that's to ensure that the battery's health and life and longevity is maximised as much as possible. So what we're doing now, this is a really nice setup. The cabling's done really nicely. You can see it's all been crimped and all been heat sealed, which is really nice. We're going to disconnect that, put the batteries actually on charge so we can get a full state of charge, and then redo the cabling. So that's the first step for us. So this is an M8 bolt that we're removing from the battery. Batteries are 216 amp hour 14 volt lithiums. These are EcoTree lithium batteries. They've got a lot of history in the battery world, and they offer some really nice products. So this is 16mm cable, and when you are wiring batteries, we need to make sure that the cable is up to the current. So this cable will be rated up to 110 amps. The fridge is going to be drawing a maximum of about 70 amps of current, so we want to make sure that the cable is up to the job. If you put a too thin a cable on, the cable will just start to overheat, potentially burn, potentially cause a fire at extreme levels. So that's really important to make sure you get the right cable gauged. How heavy are these batteries?
They're not that bad, to be honest. We've got a similar size AGM. We've got a similar size AGM over there. You'll find the.
Go on, let me have it then. Come on.
Then. Go on.
Go on. Yeah. So there's just two Victron chargers. I guess they've got up here 12 volt, 30 amp current, which is perfect. You don't want to charge your battery too fast. C5 is about right, so that's 1/5 of the capacity charge. So they're 200 amp hour batteries, kind of optimal charge rate would be about 40 to 50 amp hour per hour. So this is kind of perfect. You guys want to connect them up? We're going to need, you got some bolts?
Yeah, there's some here. Yeah.
Cool, what do we need, screws?
Just, yeah.
Okay, so we're reading 13.32 volts on the first battery. It'd just be interesting to see at the end, if we go up, up to sort of 14 volts, then we'll know that we sort of, we've reached fully charged state. Okay, 13.32. What we'll notice, just one of the things we will notice, is as we stick the current on, that voltage should jump up, depending on when the charger kicks in. There you go, 13.81. So you can see the voltage has already jumped as we're charging the batteries, and that will change as it goes through the different states. So I'll just take my positive off. So we're just fitting the Servo GX touch control, just kind of working out where everything's going before we start doing any more wiring. So this is the GX touch control. You don't need this, you can access most of the information from your phone, but you don't want the drivers using the phone, and you want the driver to be able to have a look and quickly check how much state of charge they've got left in the battery, if the solar panels are working. And I just think it's a nice piece to have on a new van like this. I think this is probably going to be one of the best places for it, and then we'll just run the cabling straight up here.
The Victron controller with quite a lot of space. Servo up there, and then the screen below it flat. Yeah. On the angle there, that's where you put it.
So we've just had a look at how the van is and kind of the current setup, and that's the work that Coolvan have done with our guidance. And we're now looking at how we can tweak the system and adjust it and improve it. We know that we can improve the battery setup into a diagonal setup, which is something that Victron really strongly recommend to make sure that both batteries are managed carefully. We're now going to add the Servo GX, the Servo GX Touch, the 4G router, and actually link all the communication systems together using all the VE direct cabling. So that's what we're going to do now. We just sort of had a bit of a discussion about the best place for everything. It's really important you take the time to design that, because you want the system to last a long time. You don't want anyone that's using the cab to knock anything or damage anything. You need to think about cleaning. These vehicles get cleaned quite heavily a lot, so all of that needs a lot of thought and care, and the planning and the design of any solar project is really, really important before you actually go on and start drilling holes. Plan, plan, plan. Make that hole once, not the second time round. So let's see how we get on. And while that's happening, we've got those batteries still on charge over here. We'll just talk a bit more about the batteries if we want. We'll just dive into lithium batteries a little bit. So Coolvan actually supplied us in 2019 with lead acid batteries for our refrigerated vans. That is a big, big no-no, and they know that. And actually they were kind enough to send us new lithium batteries in replacement. The reason it's a no-no is for two reasons. Lead batteries should only be discharged about 50% of their total capacity. Now we had the vans running and we only had 200 amp hours of batteries. The fridge had drained the battery entirely within 4 hours, and those batteries were being depleted every single day. After a few months, they'd started to sulfate, started to crystallize. They can gas. It could be potentially quite dangerous, actually. The whole thing was a big, big no-no. So as we alerted Coolvan to that, they then swiftly sent us some new EcoTree lithium batteries. They were 100 amp hour batteries in the smaller Renault Kangoo. This is a larger van. It's going to be out on longer runs. It needs much more longevity on the fridge. So these are 216 amp hour. In fact, Coolvan recommended we go for about 300 of amp hour battery, but I wanted that extra amount of capacity. We know in solar system design, it's always better to have a bit more. You never know when you're going to be on that road for a little bit longer. You never know when you're going to have these heat waves. We're here because we care about the planet. We want an electric van. We want a solar powered van because we want to put out less carbon and be kinder to the planet. And the planet is warming up. So we need to be able to counteract that. These vans are designed for food delivery, delivering cakes across the country. We don't want melted cakes. So what we've still got going on, and just to have a look actually, this is really interesting. One of the batteries, there's 3 stages of charge. There's bulk, absolute and float. Now the bulk state is where the voltage is climbing, the absolute phase is where the voltage is constant, and then the float state is where the voltage is starting to decline. So one of the batteries, this battery here, is actually in absolute, but this is still in bulk. So this, what it means is that this battery is more discharged than this battery, and that is because how it was wired in the vehicle for testing was incorrect. It was wired in parallel. It was everything running off this battery. This battery was then in parallel, so this was the secondary battery. It was much easier for the system to grab all the current and energy from this battery rather than this battery. So that's why we're seeing that this battery is actually more charged. It's almost midway through its charging cycle, whereas this battery, this Victron Energy Smart Charger, has read the fact that the voltage is lower. It needs more energy put into the battery, so it's in the bulk stage of charges. It's slowly climbing that voltage up and delivering that current to the battery. So that's just quite interesting and actually supports what we've seen in the battery before. This one's in bulk and this one's in middle stage, right? Which means that this one's more depleted than this one, which means that it was drawing more from this one and less from this one. So the evidence is there already, but it does make a difference in the long term. I
did it on purpose. So
yeah, you're testing me. Very good. Very good. So one of the reasons that we've come here is to fit the solar panels. I just want to talk a bit about solar panels. So they're called Victron. They're made from a company called BIPV and based out in Wales, which is nice. They haven't come all the way from China, and they're 115 watt, 38 volt panels. So wiring them in series, we should get up to about 80 volts, which is really good. We'll get about 5 or 6 amps of current charging our battery, and that smart MPPT there will get as much power out of them as possible. So we're hoping to get 120, 150 watts on a really nice bright day, which will be excellent, but we'll do some tests in due course and update you. But one of the amazing things about these panels, which you can't do with any other panels, is you can bend them right round. So it's great for transport and postage and things like that, and they work really well, and they come with this amazing adhesive backing as well to go onto vehicles. So these are just some of the panels that we've got, and you can see they're fitted really, really nicely, and from a kind of aerodynamics point of view, you want a really nice kind of clean, smooth finish, which we've got here. Everyone happy there? We're going to be going USB, HDMI, like that. So I just want to give a brief overview of what this is. So this is the solar charge controller. It's a smart one, which means it's got Bluetooth. So if you did want to have a look at it on your phone, you could do. It simply takes the PV input from the roof in up to 100 volts, and it will put out up to 30 amps of current, charge current, into the batteries here. And what we're just about to do now is take the V direct cable and connect it into the first of the V direct connections on the Servo GX, like so, and then we're going to connect it into the bottom here. And you'll only find here four connections plus the V direct port. Now you've got the touch connected, we've got the smart solar charge controller connected, and we're just about to connect the BMV, which means the whole Victron system will talk to each other, which means that when the charge controller is charging the batteries, it will regulate the charge according to the state of the battery, which is really important. And it also means that the servo, the brain of the system, will be telling the charge controller and the BMV what's going on, and also tell us back at base on the VRM Victron remote portal exactly what's happening to the whole system. So it really is the control center and the brain from Victron, and this will obviously display what we've got. Big shout out to our videographer Iker today. He's hiding behind his big lens, but he's been kind enough to come up with us and film this. So what we're about to do now is we need to feed the V direct cable that's come out the back of the BMV down there. So this is the battery box that's been designed. This is probably MDF or timber, and it's just been lined and it gets painted. It smells like the inside of a boat, actually. This is the fridge system up here, so it's quite a nice small fridge system that's going to be powering the unit. There's a nice light up here as well. This is the drain pipes, twin drain pipes out to drain here. I even talked about whether we could refill bottles, and then just to show positive battery, negative battery. Negative goes into the smart shunt, and you see it's got a note there, battery only, and then this is load and charger. So all the smart shunt is detecting voltage drop across the shunt, and then you've got the negative out to the rest of the setup, and then these are the two temperature sensors that will go onto the batteries. Okay, so this is the BMV 712 Smart. It's got Bluetooth functionality. On the back there you've got the comms, which is going to the shunt, and there's also a normally closed, normally open, and a communications port. And then we've also got V direct port here. Now the V direct is going to be connected to the Servo GX. Now Victron supply 3 sets of different lengths, 1.8 meter, 3 meter, 5 meter, and more. So we're going to run V direct from here all the way down the back of the van in there, and back up through this trunking here and up into the Servo GX here, which has got 3 V direct ports, and then we'll have a much shorter run from our MPPT. Smaller MPPTs, you get a light out or a load out. On the larger ones you don't, and that's because you're dealing with higher currents and voltages, so it's best not to deal with that from here and best to deal with it from the shunt. You want to make sure that your bus bars are of equal gauge to any cabling that you do, and that's both looking at the diameter, the width and the volume that you have here. So an underrated bus bar again would cause a problem because it would prohibit current flowing properly, and that could lead to high voltages and unnecessary heat and things like that. So what we're looking at here is the fridge system to the van, the cooling system to the van. You'll notice that our colleague here, Michael, sat on top of the PV panels, which is absolutely fine, because they are designed to take pressure and weight on them, so he's not going to get into any trouble from us. This is the power supply. I won't say exactly what power supply it is because I've been asked to keep that quiet, but it's a very special power supply, which what we'll do as follows. AC, 240 volt or 220 to 240, comes in through here. That will either run the fridge or charge the batteries, depending on what you're asking it to do, and it potentially do both. So potentially you could be running the fridge. Now we could be taking, this is I'm not going to state the current because that will also help find out what power supply it is, but there's more current delivered from this power device than the fridge needs to run. The fridge is about 50 amps to run, 50 to 70 amps, something about that, and there's over more than that coming in through the 240 volt supply. So like I said, it will happily run the fridge on standby mode and charge the batteries, and that's great when the driver's leaving base in the morning, happily be charging the batteries and keeping that fridge cold, and then when they're out on the road, obviously we'll switch to just battery supply. So that's the power supply, and what we're doing up here is looking for the temperature probe, because there is with this device a temperature controller which we wanted to connect to the batteries to make sure that this charge controller knows what temperature the batteries are at to ensure that it can deliver the voltage at the correct level. So that's what we're having a look at now. So the next stage of our build today, we're making great progress. We've just been up to the fridge just to check temperature sense and bring it down. We're fitting the Lithuanian Teletonica 4G router. Victron do sell a 4G router. It's great. I have read that you can't connect other devices to it, and we want to be able to connect the Servo GX and other equipment that we're going to have on board the van, such as live van tracking and other things. And all of this is much more efficient because typically in your standard home, you've got 240 volt supply, high voltage for your high power equipment. And most appliances around the home only need 12 volts. So all around the home, you've got all these small inverters stepping down the voltage to these devices, whereas here we will be more efficient because we're not wasting heat and energy. We've got a 12 volt supply and we're using a 12 volt supply. We're not having to convert it. When you convert, you lose energy, you waste energy, you create heat. So this is a much more efficient system. Okay, I release it now. I released it. Let's have a look.
Wow, I quite like that.
Someone slamming their hands on the tables. Right, okay. A GX. That's positive line. We're fitting in a body shop workshop, and next door is a diesel truck engine fixer, something like that. And he's just running that diesel, and we can feel it in the air. You can feel it. It's you know, and that's, forget what it's doing to the planet, what it's doing to us. It's strong. It's really strong. So we've got the electric clean van here with solar panels. This is the future, and next door he's trying to hold on to the past, and he should just let the past go and move on to the future. It's the bus bar covers going on. Okay, that's nice and secure, and that's nice and safe, and that will stop anyone touching that and making a connection. Hello, well, welcome back. We are just fitting some conduit to the 4G aerials. Everything is really neat and tidy before we progress, so that's where we are with the project so far.
It's blue, not red, so it goes with the red.
It goes, all right, we'll go with the blue.
Yeah,
let the blue shine through.
Yeah.
What are you thinking? Or
you follow the drain pipe.
Follow the drain pipe, all right.
Tuck it out of the way towards you.
All right, so we do something like, okay, so something like,
that's it. Yeah, I'd say that. Yeah.
Right, well, we finished our wiring. So just to talk about the components, we've got our DC bus bars down here, positive and negative. That's all running up through this vein here. I mean, it really is like a vein in the human body, because this is all the communication and data and energy and electricity flowing up and down here. We've also built in our own cooling system. It's not a real cooling system, but we're getting water from the fridge, any condensate running through here, which will actually cool down some of the cables. And this is all our equipment. So as we said today, we've got the Victron Servo GX Touch, the Teletonica router, Servo GX, Smart MPPT, and the BMV 712. So this is everything that we've got in the equipment. What we're doing now is just connecting a temperature sensor, because the Servo GX has loads of ports available. So we're going to connect the temperature sensor to the rear cabin, the chill cabin. On the VRM portal, we'll be able to see the temperature live of the vehicle in the back, which will be very useful for us for food safety standards and things like that. And then we're ready to put our batteries that have been on charge all day back in, set them to 100% fully state to charge, test the system, make sure it's all safe, and away we go. And we've done a really good job, and everything's been fused really nicely. We've got all our fuses in place, so yeah, really happy with how it's turned out. We're gonna go back. Sorry. 27 kilos of lithium iron, all the way from EcoTree. So we're going to install our first battery, and there's already some braces here. We may decide to add some extra belts around it, but it's in a nice tight cavity, which is good. We want a bit of ventilation around the battery, so anyway, we'll have a look. Okay, so we've got our negative connection here from the bus bar. It's a 500 amp bus bar. It's 2 temperature sensors that are going to read the voltage and temperature of the batteries, and we've got our negative connection here and our positive here, and there's a negative out the bus bar to the rest of the van's equipment. So we're going to first of all connect the batteries in parallel. We're connecting in parallel, not series, because we want to maintain the 12 volts but step up the capacity that we've got of the battery. So that's the first thing that we'll do. What's really important is that both the cables are of the same length. That's really, really important. Looking at resistance, you want the cables to be the same length and appropriately gauged for what we're doing here to ensure that we don't have any problems. Then we connect our positive. So first I'll just connect our positive of the batteries, and we're going to run the positive of the system off this battery, and that we've got negative of this battery, positive of this battery, so the distance that the power and current is having to travel is the same and matched. It's nice and quiet because everyone's in suspense as the system goes on, that we don't see any sparks or anything like that. No, it will all be fine. We've got appropriate fusing. We've got fusing on all of the consumers, which is really, really important in case there's a problem, so that's no problem. Right, I'm going to make the final positive connection. Okay, so we've got our diagonal configuration here, so positive this battery, negative to the system to that battery, through the shunt, all negative loads through the shunt and into the system. We should, if we go into the cab, start to see some activity. Let's go and have a look in the cab. Fantastic! We have got action. So we've got the Victron Touch GX on, photovoltaic charger. So you can see that. We're going to tell the system in a minute what we've got connected. We can see that the router is receiving signal. We can see the MPPT. Now we're not seeing anything on the BMV 712, so we need to have a look at that and understand why. So we'll have a look at that in a minute and just understand why that's not connected. Could be a cable out the back that's not connected, but we are seeing power across everything else, and we'll check the network as well. But all looks good, all seems good, and like I said, we'll just check the BMV. We made a small mistake. It's all about learning here. We didn't connect the positive to the BMV 712, so we won't get any information from that. So we've come back and we've realised that in our excitement of connecting all the battery systems, we've forgotten to connect those. So we're just removing the positive connections. We'll add those back on and then we'll go back inside. Okay, right, we should now see the BMV 712 on. Let's go and check inside the cab. Okay, so we are all systems go here. So what you see is, you can see it's identified the different pieces of equipment. Yeah, so it's identified the MPPT. It knows it's connected to the BMV, so that's why we're getting the 11 watt reading on the batteries. Good. I think what we're going to do now is put the fridge on AC charge and just test that charge is working and that the batteries are receiving current, and we'll see if we can see that from the from the GX Touch. That's the next thing that we'll do, and then we'll do a bit more configuration, and we're pretty much done. This is the Victron Connect app, and I can see lots of things here. I can see actually the battery chargers we've got in the background. I can see the Servo GX, the smart charge controller, and the BMV 712. We can see what current coming out of the battery, about 12 watts of power. It's giving us the time remaining, it's giving us the battery voltage, which is great. And all that information I can also see on the screen here. We've installed that screen, so there's a great overview for the driver. It's a 16 amp commando socket we're using. There we go, fantastic. Okay, fantastic. So we can see charge current is climbing to 65 watts, 65 amps, 64 amps, about 900 watts of power. That is grid power. We're not doing it from solar today, but we're hoping that in the future, all the power that we'll be using will be sustainable. But that's fantastic to see. The battery's just showing 100% state of charge. That's because we haven't calibrated the system yet. What would be advisable is to leave it on, leave the batteries to their fully charged, then configure the system, and then you'll get an accurate state of charge. And you can do that through the Servo GX or the BMV. We'll do a few different tests now, but what we can, in fact, we can run the fridge while we're using the AC load and just see how that works, because the fridge is designed to. So what we should see here is we should see the current coming into the batteries drop as the power is diverted to running the fridge on standby. So we're going to go ahead and do that. I'm doing that here. Okay, I've just activated the, it's all okay up there, yeah? Yeah. Right, I've just activated the fridge. We can see that the charge current has come down to 43 amps, so it's taking about 200 watts. So it will start, it will cycle, but our power coming into the fridge, our power coming into the batteries has significantly dropped down to about 600 watts. So we've lost about 20 amps of current charging the batteries, which is not bad at all, and we're now running our fridge. So we'll leave that on as we're testing it for a while. And that's great because we're still getting to that plenty of charge into our battery, and as we said earlier, and able to run the fridge. So that's very exciting. And still no watts on the PV charger, but don't worry, we're going to wheel the vehicle outside and just test that that PV's working before we lose sunlight. So hopefully it's a nice bright day up in Lancashire, and we'll see what's going on there. But anyway, really good news. Let's just go inside the cabin and just see how cold that fridge is. So it's probably quite noisy in here, but we've got lovely cold air coming out of this GAH 12 volt fridge, all working very nicely, and that will keep all the product really nice and cold. So we'll seal up our battery bank now, we're happy with it, we'll make sure everything's nice and tight. All right. So we're rolling the LDV Maxus out for the first time, driven by one of our next day solar drivers, and we're wheeling it out just to test the photovoltaic panel. So everything else is working, and you can see the Servo GX Touch LCD display. Now it's not a bright day, but you will always see voltage from the sun. That's that natural iridescence of light, so that's what we're testing it. And you can see inside, looking through, you can see the flash of the Servo GX, and you can see that Servo GX touch display sitting up there, which is telling us everything that's going on. And the van looks great. I think the LDV have done an amazing job with this van. It just looks fantastic. It really does look brilliant. And it's silent, you know, we can wheel it in and out of here, no problems. It's one of the benefits of an electric van. It just looks fantastic. Good job. Right, so we're going to check the solar panel on the top of the roof. How's it drive?
Yeah, it's fine.
Okay, 9 watts, right. So we've wheeled the vehicle outside, and actually we're running all the systems and we're not using any power because we're generating it. So we're generating 9 watts of power, and whereas when we were in the body shop you were seeing minus 10 watts, minus almost 1 amp of power, we're not seeing that now, so we're getting 4 watts. So we know kind of the operating wattage of all this equipment here is about 10 watts, and we're able to make almost half of that on a very cloudy, horrible day. So that's great, great news. And that's powering the controller, the Servo GX, the screen, and all sorts of things. And I can just test it here. I could even unplug the screen or unplug some of the elements, and you see, but we're generating more than we're using. So this current system is neutral in a very, very cloudy day. And then obviously, as we see, if we're lucky, if the sun comes up, we'll see that PV charger wattage increase. We're in bulk mode here, so that light's come on. So we're in bulk mode. There's bulk absorption and float. That's sort of where it's saying, right, batteries need charging, absorptions where they like to be almost fully charged, and float where they're fully charged, and it's just kind of maintaining it. Great, so we're getting 40 volts, which is great. Now the panels are 38 volts. Obviously it's a very, very cloudy day. They'll fluctuate depending on how much light they're seeing from the sun. And on a very, very bright day, we should see that peak at about 80 volts. And we'll be watching that carefully. And the MPPT charge controller will be tracking the voltage, trying to get the most. You can see we're almost at 50 volts there, which is great. So we're getting 11 watts of power. That's great. And we're really, really happy with all the Victron kit that we've installed today. We're going to add our system onto the Victron remote portal. We'll be able to see a lot from it. So I'm going to add in my Victron remote portal ID. You can find that within the settings of the Servo GX, and my wonderful colleague Saeed is going to share with me the number. Okay, so we just request access. Okay, so name of the installation. So we can give the installation a name. Load as Maxus, eMaxus 1. And I can see exactly what I can see on the screen inside the Maxus, which is, okay, we've got the battery that's idle, it's consuming 9 watts of DC power, and there's no PV power coming in, and there's lots of other things we can do here. But what it means I can do from here is I can actually remotely control and change the settings on the van from anywhere in the world. So if you've got a customer that you're working with, or if you want to got your own system and you've got vans on the road but you need to change some settings, you can do that all from here, and there's tons you can do in here. Great, well we've tested the system and everything is brilliant. So we are now just fitting some safety battery covers onto the batteries, and that's just to ensure that all the terminals are covered and safe. Nothing's going to get in here, but in case anything would, it's just good practice to put a rubber terminal cover on there. That just makes sure that nothing can short the batteries. So we're just going to feed them through and then just place them. There we go. So just want to say a big thank you to EcoTree Lithium for helping us with these batteries. You can see we've got that lovely shunt set up there in the corner. That's a nice tidy battery setup. Let's have a look at it, what it looks like from the front as well. I tell you though, it would make an impression, you know, because you don't really see the panels there, but you do here, you know. I mean, you add another 50%. You know, onto your power generation. You know, we then go on to a cloudy day in generating our own power. Well, thank you for watching the installation of this LDV eMaxus Deliver van. We've had a great day here at Cool Van installing all the equipment. Just as a recap, remember we've got that solar panel roof on top, and we've installed all that Victron equipment, the MPPT charge controller, the Servo GX device. We've got a 4G router in there and the BMV 712, and that's all talking together. We've got that on the VRM portal, and we can't wait to use this van. We've got a sustainable van here, carbon-free from an emissions point of view, carbon-free emissions vehicle, which is also going to charge the fridge through the onboard solar panels from BIPV. And big thank you to Victron, big thank you to EcoTree Lithium, and big thank you to BIPV for helping us with all the equipment. So thanks for watching, and see you soon. And thank you to all the team that were helping today. Round of applause to them. Round of applause to them.